Hey everyone. In the last video, we learned how to set up Terraform with minimal configuration, how to build some basic required blocks for our project, and how to create a custom module and generate a Kinesis stream with it on AWS. Now in this video, we'll finish setting up the rest of the pipeline, that is configure our S3, Lambda, and ECR, and demonstrate it end-to-end with a relevant example from our use case. So let's get started. Now at first, let's reference another Kinesis stream in our base level main.tf file for the consumer side. So let's call this. So this one is our ride events. And this is our ride predictions. And let's call this something like output Kinesis stream. Call it whatever you like, consumer Kinesis stream, output Kinesis stream, target Kinesis stream. And let's call this variable also output Kinesis stream. And let's keep the rest of the configuration the same. What we are doing here is instantiating another module of this particular type that we created in our last video. So that we have a pair of Kinesis streams now. And let's head to the variables and variable output stream here. Okay. Now, the next thing we'll do is we'll install and configure an S3 bucket for our model artifacts. This is going to be this is one of the easiest modules to configure actually, along with Kinesis. So what we'll do here is just like Kinesis, we'll create a main.tf file and a variables.tf file. Okay. And in here we'll define a resource for the AWS S3 bucket type, and we'll call it something uncreative like S3 bucket, but it's self-explanatory. Call it whatever you prefer. We'll also require an input value to our bucket name that we'll be creating through Terraform. So note that this is not the same bucket as our state bucket. A state bucket that we created in our previous video, which is here, was manually created before we initialize and apply our Terraform project for the first time. This particular bucket is something that is created during our Terraform project. So it will be created by Terraform itself. And for this, we'll be taking a variable. Oops. Right. Yeah, so that's it. We are keeping our ACL for private. You can check on the terraform.io or HashiCorp's page for the AWS provider plugin that we're using and this particular resource type and what configuration is needed. We're keeping most of the settings as default, but we just want our bucket to be private. Yeah, and in addition to this, we'll also output We'll also create an output variable for the name of our bucket. So you can reference this as AWS S3 bucket dot the name of our resource dot whichever property you want to reference to. Many a times in you may also need to output the ARN for the bucket and configure it in, let's say, your IAM roles and policies to grant access to that bucket. But for now, we'll just make use of the bucket property, which is going to return the bucket name. The source Kinesis stream that we created in our previous video is something that I already destroyed via Terraform the previous time. I can show it to you here. There you go. Please make sure to destroy your Terraform resources after you've done for the day's changes to avoid any unnecessary costs, although the components that we are creating would not charge you unless you're using them, but it's always safer to not keep any resources idle on your on the cloud unless you want it to be persistent. Okay, and here we'll be referencing now the S3 module. Okay. We need to pass a bucket name, variables dot name. Let's call this S3 bucket. Okay, and let's have this configured into our variables file, root level variables file. Just for the sake of our use case level understanding, let's say if you're sharing this project with another developer at work, and for them to understand what is this bucket referencing to in their use case, then with respect to our example or within our workshop, this is actually our model bucket, right? So let me just add some context here. So this is our model bucket, and let me just call this variable name also as model bucket. Oops. And let's also attach our project ID to that naming, so that all of the resources in our cluster for that particular project are all together. Terraform also requires that you reference variable names within the strings in as how you would do it in a bash style also, that is with a $ and curly braces with it. So this is what we are formatting it as. Okay, let's also try to give this a run. So So now there are 2 new models detected, an output Kinesis stream and an S3 bucket. The input Kinesis stream was already on the explain plan. So what value should we give to our S3 bucket? Just like in the last exercise, like I'm appending the keyword stg, not keyword, but this value stg to segregate it from the production resources that I already have created on cloud. You can also follow the same suit, or you can follow your own custom naming as well. Another thing is in the earlier exercises or for the previous weeks, you may have already created an MLFlow models bucket. Alexi must have shown that bucket where you're actually storing your S3 artifacts, and I think he called the bucket as MLFlow -models -Alexi, and you chose to either go ahead with that or slightly modify the name. So we'll be referring to the same bucket, but try not to keep the same name. We'll be creating, basically we are showing here how to create such a bucket to store your artifacts, to store your model, for example. And for this reason, we need to create a similar name over here. For your output stream, maybe I'll call something like this. And because I already destroyed the Terraform resource for the source stream earlier, I will be again creating this one. So here you go. Okay. This is an argument that you can ignore. Currently, the Terraform.io's official page for this particular resource does signify that we can use it, but Terraform itself is like throwing a warning that this is deprecated, but it's not something to be worried about, so we can ignore. And yes, now we have 3 resources. 2 Kinesis streams and 1 S3 bucket to be configured. If you haven't already destroyed your source Kinesis stream, then you might find this to be something that can be modified, or it might not just appear in your plan. So it could be 2 to add and 1 to change, or just 2 to add in general. Okay. And let's apply this. We'll have to give the same values. So the source stream. Yes, we approve. This will take a couple of minutes. And that, nice. Okay, now begins a slightly tricky part. We'd be configuring our ECR registry, and then we'd be configuring our Lambda. Now, with respect to the ECR registry, basically we are creating a repository that can store the Docker images for our Lambda service to run. The trick here is in Terraform, all of these modules that you create in your base level Terraform file, all of these are generated in parallel, which means the source Kinesis stream is being generated while the output Kinesis stream is also being generated. And so is the S3 bucket. And we want our Lambda to have we want our Lambda to have dependencies on all of these. That is, all of these resources should be created before the Lambda is created. Otherwise, it may not find the S3 bucket that it's supposed to pick the model from. It may not find the source Kinesis stream where it's supposed to pick the source event from. Similarly, it would have a high level of dependency at compile time on the ECR registry, where it's at the very first thing that a Lambda would need is the Docker image to run on. And if that image URL does not exist, then definitely our Lambda configuration would fail. And for the other dependencies that I just spoke about, that is for Kinesis and the S3 bucket, it would fail at the runtime if the model or the source stream is not present. So this is why this is going to be a little tricky. Let's start with main.tf and variables.tf. And now, so the very first thing that we need is our ECR repository resource. We are calling it something straightforward like repo. At a minimum required parameter level, we need to provide it with a name. So let's configure that here. The other settings are just recommended ones. So we are setting our image tag mutability to mutable, image scanning configuration as false for scan on push. Nothing to worry about in case of these settings for now. Yeah, the next thing that we would need is, now this is a very important part to focus on. So what we are going to do here is, like I explained before, we need to set a certain dependency on the existence of the Docker image in the ECR repository for Lambda to be able to configure at the Terraform step itself. So generally what happens is, in practice, companies usually have two different repositories for your application code and for your infrastructure and for your base infrastructure code. The base infrastructure code generally contains base level components, including your ECR repository, that do not really need to change over time. However, on the other hand, that is the service side of the repository may contain some service-specific IAC code, such as your Lambda configuration, that may need to be updated once the location of the Docker image is already available. So the dependency is kind of managed by CI/CD here, assuming that the infrastructure repository will have already deployed the latest infrastructure and the application repository can lean onto that. However, in our repository, we are doing everything in a monorepo style. And this is the reason why we need to create a dependency resource onto our ECR repository before the Lambda generates itself. So this is basically what I've explained here in a nutshell. We are going to make use of a null resource, which is a special type in Terraform, which is not a plugin that is not imported from any official provider, but basically it belongs to no type in general, and we are calling it an ECR image, or you can call it anything, but this basically in our use case is referring to our ECR image resource. which is our dependency. The other thing is you can choose to create only the ECR repository in a base infrastructure repository and just upload your ECR image via CI/CD pipeline, which is generally what is done in practice. Before your application repository, runs its source code onto that particular ECR image. However, because we have all coupled it into one workshop here, we would also need to push the Docker image from here. And for this, we will be pointing to our Lambda function, which is something that Alexei would have shown you in the previous videos. This was basically the Lambda handler, which will be coupled into your Lambda configuration along with the prerequisites setting. And we'll be needing the Docker file from this location also to package your Lambda into a Docker container and push it to your ECR registry. So yes, we'll be providing the locations of each of those files. We'll be also passing the region for the creation of the ECR repository, as well as where it is supposed to push the image to. We'll also be needing the account ID, and this is the reason why we referred to the AWS Scholar identity in our previous video. We'll be fetching the repository URL from the ECR repository resource that we created above this. And we'll be taking the input image tag from the variables.tf, which could be something like a latest, the value latest, or it could also be SHA ID or a hash ID. But we'll keep things simple here and use latest. Okay, so let's define the variables for these. Okay, it all looks fine. We've kept the account ID as blank here because we are directly going to pass the data source. Okay, now let's go back to the other thing to notice here is the provisioner block nested within this null resource with a local exec naming. Basically, this provisioner block allows us to execute a certain command. In this case, it's a bash command to, basically the commands that you pass here can be executed on your virtual machine. And the triggers block will actually help us track changes to the file locations that we are passing here. And this will also help the Lambda container, help determine if the Lambda container has changed. And with the MD5, we get a hash of the specified files. This would mean that if we make any changes to the Docker file or to the Lambda handler code, then the Docker image will be rebuilt and uploaded to the ECR repository. Okay, so now finally, the next thing that we'll need is now we'll be configuring our ECR image as a data source instead of a resource. We'll call it Lambda image, and this would be depending on the creation of this ECR image. And it will take the values as required by the AWS ECR image resource configuration. The mandatory values are the repository name and additionally the image tag. And yeah, finally, we'll be outputting the image URI, which is dependent on the creation of AWS ECR image, which in turn is dependent on the creation of the actual ECR image of the null resource type. Okay. So now we are done with the ECR configuration. Let's configure this into our base level main.tf. So let's call our module the ECR image. It's referencing the ECR module. We'll need to pass the ECR repository name at runtime. And we are passing some mandatory or required parameters for this particular module that we just created, such as the account ID, the Lambda function local path, and the Docker image path. And in variables.tf, let's create variables for your Lambda function local path, the Docker image, and the ECR repository name. So now it's all done. What values we'll be passing is something that I'll show when we are executing this project. Now let's also check the Terraform plan for this, if everything is all right and if there are no syntactical errors. So new module detected. Okay. It's also pulled HashiCorp null from the internet. Okay, so now that we are realizing that we have to input a lot of variables at runtime, let's introduce something called as tfvars, which is something that we can preserve our variable names into and then pass it into our Terraform commands. So think of this as an environment file in your Python application, the .n Python file where you set your environment variables with respect to that particular environment. And then when your application is running, it directly picks up these environment values based on the path that you've set and the local environment or even the virtual environment you're running into. All right, so what we'll do here is create something called as a new directory called as vars, let's say, and you can also keep this at the root level along with your root level files. And let's say we have one for production and one for staging. Let's just call this variables or resources that are created for this particular environment. So yeah, just something like stage.tfs. Okay. And in here, let's copy all of these variables that we are supposed to enter at runtime. So one is the ECR repo name. Then we have the ECR image tag is already set to latest. This is bad. Okay, so we already have the defaults for region and project ID. We keep one for source stream, one for output stream, for model bucket, the Lambda function local path, the Docker image local path, and the ECR repo name. Okay. And now just use this as any environment variables files with a value assigned by a string. So your source stream name is, I think we kept it stage ride events, right? So this, your output Kinesis stream is staging underscore ride predictions. The model bucket is something to do with the MLFlow models. Keeping a similar naming convention as earlier. We have just appended the stage prefix to one of our earlier model buckets. The Lambda function, the path of the Lambda function, let's see if we can find it here. Okay, it doesn't pop up. So currently we are in the infrastructure directory. So we go to one level up at the code directory and then locate the Lambda function file. So we can also just copy the path. I've kept a relative path here. We can also keep an absolute path. There's a way to designate the current working directory that can be understood by Terraform. It's a system-specific variable for Terraform. That is something that we can introduce. I'll be introducing a little later. Let's stick to relative paths for now. Similarly, your Docker file is also located somewhere here. And the ECR repo name could be something like let's keep it this. If it's used in the previous examples also, stream model duration and yeah, with an environment name attached to it. All right. And now let's try giving this a run. And in order to pass the variable file, this is how we would do it. So hyphen variable hyphen file is equal to the location. So it's var slash stj.tfvars. Actually, I don't think we need the quotes. Yeah. Oops. Okay. So now it's apart from the ones that we've already created, which is the S3 bucket, 2 Kinesis streams, and the data resource for the caller identity. Like you can see, now there are 2 new resources to add, apart from the S3 bucket and 2 Kinesis streams with respect to their ECR configuration. So one is the ECR image and the other is the ECR repository. All right, and so we won't be running an apply, or maybe we can actually. Let's just run it in a similar fashion. Login succeeded. It's creating the SHA image. This should take a few seconds, but until then, let's just revise what we did at the moment. So so basically the current step that's going through is a typical step that you would run in your CI/CD pipeline, which we are actually configuring via Terraform, where it is building the image and pushing it to the ECR registry. We are doing this here because we want to, because our Lambda configuration will require dependency on the image URI. An existing image URI that will be returned as an output once this is available on the cloud. The other workaround that you can do is also you can keep a vanilla minimalistic Docker image in your infrastructure repository, maybe something like a blank Alpine Docker file, a Docker file with a blank Alpine image, which basically does nothing, maybe an echo. And you can also push that over here. Because basically we just need some image that has a consistent URI with the latest tag that your Lambda configuration can point to. And in your CI/CD pipeline, we'll anyway be building and pushing and updating the Docker image in a separate workflow, which the Lambda can anytime pick up from. So this is also another alternative, just saying, in case your this particular Docker file is very large for you, then you can make that happen as well. So while it's building, let's move on to the next parts of the infrastructure code. Okay, so the next thing we are going to do is the main module, which is Lambda. And for this, oops. Okay, and for this, we create so in your Lambda configuration, for this particular resource, a Lambda function obviously needs a function name. And apart from that, it expects a package type, which could be either zip or an image. And if you're passing an image type, then it expects the next argument to be an image URI, which is the location of the Docker image on the cloud. This is either your ECR, either on your ECR registry or a Docker Hub or similar container registry. It also expects a role, which is something that we'll be talking about next. And apart from this, this step is actually optional. These are certain environment variables that we are configuring for the Lambda. We are passing some static values here, but this is not important for now because we'll be anyway updating the configuration of the Lambda in our CI/CD pipeline. And passing the freshest environment variables there. So you can skip this step also. Apart from that, we are also assigning a timeout just for safety in case our Lambda takes a little while to process. And this is also a Docker image that we are processing, right? So yeah, based on the bandwidth and the configuration that you currently have for AWS, feel free to adjust your timeout. I have kept it to 180 seconds at the moment. Now let's talk, before we begin with continuing the rest of the configuration here, let's talk a little about the IAM role. So since we already saw that the Lambda will have a lot of dependencies on your Kinesis streams to read the input from, to write the output to read a certain model artifact, and also to take the Docker image from the ECR registry in order to process your application code, source code, right? So in that aspect, we would need to create an IAM role specifically for this Lambda to be able to interact with all of these resources. So let's add an im.tf file here. Again, this is not important. You can add your IAM roles and policies in your main.tf also, but I'm choosing to keep it a little separate because we may be needing a lot more policies. So just for easy organization here. Yeah. Okay, and within our IAM role, firstly, we'll be creating a role called as this. So yeah, the resource type is AWS IAM role. Initially, when I started with this project, I labeled this as Lambda for Kinesis, but let's just call this IAM Lambda, okay? IAM Lambda project ID, so this, we can pass it via the variable name also, that is the project ID. Let's just keep it this way for now, or if you want, you can just append an environment variable to this. I'm doing this because I want to keep it separate from the role that I've already created on cloud at the moment. And we are assigning it to principal level permissions, that is to execute Lambda and to be able to execute Kinesis. Okay, so these are the base level permissions that we are passing for this role. And now we'll be attaching further policies to it. So first one is a policy to allow Kinesis processing, which means it should be able to list the names of the Kinesis streams and get a particular record from that stream and so on and so forth. Also put a record into the stream likewise. And then the third segment that we'll be needing is role policy attachment. So we currently have a role, we have a policy, and now we are creating a resource to attach this particular policy to this role. Okay. So the name that we give to our role is IAM Lambda, and we want to extract the name for it to assign it to the role parameter here. And for the policy ARN, we once a policy is created, it will extract its ARN and assign it to that particular role's policy ARN. Now this is like a 3-step format that we can do for each set of role policy and the attachment. Similarly, I will also create a policy for basically there's an inline role policy. This is for putting the records in to the output Kinesis stream. The first one is for getting the records from the Kinesis stream, and you can I have not exactly assigned the kind of resource here. I've kept it open, but you can change this to make it restricted to your input Kinesis stream here. Yeah, I am restricting the putting records permission to the output Kinesis stream. So I'll be passing this as a variable into this module as well. In this particular policy, I need the ID for the role that we created. So there we go. And this policy also depends on the creation of this particular Lambda. So go. Okay. And okay, so this is what we'll be needing for your Lambda to interact with both the Kinesis streams. We'll also add a variable here, output Kinesis stream. Oh, we need the ARN for that. Okay, my bad. So one thing that you should notice is the resource requires the ARN of the other resource that you're trying to give it access to. Now, how do we generate an ARN if we do not know what particular, before you even create the resource, right? So because this particular project will be executing it all at once. So your Kinesis module would be generated at the same time as this particular IAM policy. So definitely there is a dependency management to be maintained here as well. So what we can do for this is in your Kinesis module, you will notice that we had created an output variable on the stream ARN earlier. So this is where like once the resource is created, only after that it would be able to output the ARN of the resource that it's generated, and it will pass it back to the root level main file, which is here. And when we create the module for this particular Lambda, which is still in process, we'll be referencing this particular module's output as the input to the Lambda module. So I'll show you in a bit how that looks like. But for now, let's just take this as our, let's just assume that we have our output stream ARN as our input. Okay, then further permissions that we'd be needing are something to do with CloudWatch logging. So let's have that in place as well. So yeah, we are defining a Lambda permissions resource. Okay, let me just skip this part for later. This is just for logging alone. Basically, we are granting the Lambda the policy to allow logging in the CloudWatch events, CloudWatch log groups, I mean. And over here, again, we are attaching this particular policy to the same role as earlier. So okay, and the policy ARN is the ARN of this particular resource. The next one is the set of permissions for your S3 bucket. So over here, I am granting it action to list all my buckets and get a certain bucket location for any bucket. I'm also granting it permissions, restricting to the specific bucket that we are passing as a parameter to this particular module, which is the model bucket that we just created some time ago through this module. And along with that, some standard CloudWatch logging permissions. And we are going to attach again that policy here. So here you go. And we'll be passing this as a variable name also. So cool. So in this particular case, because we already have our IAM file. Yes, we already have our IAM file within the same module. We don't really need to create an output variable to output the ARN for this particular role and then pass it into this particular resources parameter. We can directly reference it as long as things are within the same module. So when I just you just saw, like, when I just referenced it with a dot, it automatically showed up what role currently exists in my module. So I chose that, and I'll be choosing the ARN to attach it to the role parameter here. The other thing, like I explained, if we are declaring a package type as image, then we'll be needing the image URI as well. So let's assign variables for your Lambda function and image ARI both. So go. Now it is all fine. My ID is actually throwing an error because it is expecting properties such as handler and runtime. And this is a bit of a bug with respect to PyCharm's Terraform plugin. By default, every Lambda function resource should expect a handler and a runtime. That's true. Your handler is a location of your Lambda handler function. And the runtime is, let's say, the code environment and version that you're running on, for example, Python 3.8. However, in our case, because we are running a Docker image, we do not need to, actually, we are not supposed to pass it, because this should be kept in, basically, this is a black box environment for the Lambda, and it does not need to concern itself with what Docker image. It just needs to concern itself with the running or execution of the Docker image, not what is within the Docker image. So yes, regarding the environment variables, like I mentioned, this step is optional, and we'll be anyway updating it during the CI/CD process workflow. Yeah, but just to give you a context, the kind of variables that we are passing here are the static values of your prediction stream name, which is the output stream that we are creating via Terraform, and also the model bucket that we are creating here as well, which should grab your model from. The third variable that your Lambda will be needing, as we can see here, is actually the run ID. And this is the latest hash ID of your model version. So this should look something like this. So let's go through the MLFlow models bucket that you created the last time, which is here. Yeah, and within this, you will see the partitioning is with respect to there's a number followed by a hash ID, followed by the artifacts keyword, and then comes your model partition, and within the model partition is your model pickle file. And what we need is actually the hash ID here of the place where we are supposed to pick the certain model version from. This is what is needed as your environment variable as well. Let's just, so that's another environment variable that's needed, which we do not know of as yet because we are just creating our model artifacts bucket in this particular configuration, the one that you noticed with the prod prefix. Let me just share that again. What we'll be creating via Terraform is actually a replica of the MLFlow models bucket, which will be something like MLFlow models and suffixed by the project name. And based on the environment that you're creating in for your local, we are using the stage environment variable, and within your CI/CD workflow, it will be your prod variable. But when Terraform actually creates it, it'll obviously be empty. And what we are actually going to do is we will be manually or programmatically copying the artifacts from your earlier exercise into the Terraform generated bucket and then executing the Lambda. We obviously in practice, this is not a step that we do. Generally, the workflow is like the infrastructure or the IAC Terraform code comes first in order to create the base level infrastructure modules, such as the model artifacts bucket and the ECR repository, and also the Kinesis streams. The next comes the model training or retraining process, which deploys your model into your model bucket. And then comes the application code workflow, where we are writing some Terraform code in order to generate the Lambda configuration and have a CI/CD workflow to update the source code of that Lambda and also deploy your Docker image for that Lambda into the ECR container, ECR registry, and also pick up the run ID of your latest model version based on whatever MLFlow is actually showing us. Now, the other thing that this Lambda configuration will need, or let's say this entire end-to-end pipeline will need, is a Lambda trigger. We definitely want this Lambda to not be scheduled or to run on demand or manually to execute it manually. We want it to be triggered whenever a new event arrives in your Kinesis stream on the producer side, which is the write events. So let's go to creating that particular Lambda trigger. So one thing that we'll be needing is a Lambda function event invoke config, which takes in your Lambda function name. and just configures your event age and the retry attempts, just operational stuff. The main part is actually the mapping of the Lambda event with its source. In this case, it's the source Kinesis stream. We are labeling it as Kinesis mapping for this particular resource. And what we'll be passing here is the source stream ARN of the producer Kinesis stream. So if we do not have that already configured, let's do that. Let's pass both the name and the ARN of the source stream. Great. And then you'll be needing the function name. It's generally accepted to preferred if you pass an ARN. The starting position is latest. This depends on the Kinesis processing policy. So this means basically when a Lambda is triggered, then this event should occur, and which has the permission to process the Kinesis streams, which is what we've assigned here. And these are the permissions. And now finally, we will also add this permission for the Lambda to be triggered. What we assigned earlier was like what will happen once the Lambda is triggered, and what this will allow CloudWatch basically to invoke a Lambda function, which is something that we've defined here. And this happens when the source is actually generated in this particular stream. Yeah. Cool. And further parameters that you can assign is enabled, if the event source mapping is already enabled or not, and what batch size you can allocate for that, but it's not important for now. Cool. So we have everything ready almost. Let's just reference this into our base level main file. I'll keep the name as something very obvious, such as a Lambda function. And let's automatically add the properties. So yes, this is where the output variables play a major role in creating the dependencies. So this is going to be interesting. So for your image URI, I'm going to refer to the module that we've referenced above, and we want to get the ARN of the ECR image, or let's say the image URI output variable that we created at the end of the resource creation, which is here. For your Lambda function name, this would be something that would come from the variable itself. So something like this. The model bucket can also be referenced from the output variable of the SPG bucket. The output stream name is, actually this can also be taken in from the same. Let's reorder this a bit. So output Kinesis stream is the same as this. Your input Kinesis stream is also the same as this. And your stream ARN is your output variable. Similarly for the source. There, we have it all. Only thing we need to pass now is your variables. Let's define a Lambda function name, and in your tfvars, let's define the value of the Lambda function name. Let's call it something like stage prediction Lambda, or something like stage ride prediction Lambda, whichever you prefer. Shall we give this a run? Okay, so we already have this available here, which is our ECR repository and an associated ECR image uploaded there. Let's now reinitialize this. We have a new module. Let's run the plan with the updated variables file. Cool, 11 resources to add here. So there are a few IAM policies to allow Kinesis processing and login and to access the S3 bucket. All of these policies attached to your Lambda role. We also have a Lambda function and the event source mapping for that particular, the event trigger for that particular Lambda. You can see some environment variables also updated here based on the output of the resources that we created as dependencies. And yeah, let's apply this. We have some errors, and this is because one of my previous deployments already had certain policies created with similar naming. This is also the reason why it's recommended to pass the environment name as well as the project ID to each resource you're creating so that it remains within that cluster of deployment. Let's try to fix this. You may not receive this error, but in case you ever do, this is how you can do that. So the first thing that we found an error on is like a duplicate resource called allow Kinesis processing is already existing. And as you can see, this is a very static name. This is not dependent on any project ID or environment keyword that we are, tag that we are passing in this naming. So since this is the Lambda module, let's see what parameters we are passing in our Lambda module here, which has both our project ID and also the environment name. In combination, I think a Lambda function name would be more suitable to use here. So let's give that as our variable name. Right. We're doing this because anyway, this particular role and set of policies are dedicated to this particular Lambda. So you can have your policy attached to this particular ID or function name also. That is also fine. Let's do that for the other ones. So there is an issue on allow logging and Lambda S3 policy. S3 policy. Let's just confirm the names of all the other policies also. Maybe we can name this. Okay, so far it's not thrown an error, and this is Indian and policy. Okay, looks good. And now let's give this a try. Kinesis processing, logging, S3 policy. This is stuff that we updated the naming, and therefore the policy attachment had also changed. And also the Kinesis mapping, which is dependent on role ARN. All done. Now, shall we give this a run, like end to end? Let's see, by trying to put an event into the source Kinesis stream, what really happens behind the scenes, and if we actually receive the output for it or not.